Imagine standing at the edge of a tunnel, not just through space, but through time itself, a doorway that could fling you across the galaxy or hundreds of years into the future. Science calls it a wormhole. Movies call it time travel. But could it actually work? Buckle up, cadet. Let's dive into the wildest shortcut in the universe. Think of space as a giant sheet of paper. Now, fold that paper until two distant points touch. Punch a hole between them. That's a wormhole, a theoretical tunnel predicted by Einstein's math, connecting two places in spacetime. It's not just a bridge through distance, it might be a bridge through time. But here's the catch: we've never seen one. Wormholes live in the equations and in our imagination. If space and time are woven together, then moving through a wormhole doesn't just move you somewhere else, it might move you someone else. Picture this: two mouths of a wormhole. One stays parked somewhere safe. The other, we strap it to a ship and blast it near the speed of light, or maybe park it close to a massive black hole where time crawls like molasses. According to Einstein's theory of relativity, time at that fast-moving or high-gravity end would slow down compared to the one you left behind. Now imagine years pass on one side, while only hours pass on the other. Then, we drag those two ends back together. What do you get? A tunnel where stepping through is like stepping into the future. You walk in on Monday and step out on a Friday 50 years from now. And it gets crazier. Some physicists speculate that if you could somehow control the ends of a wormhole, move one forward, keep one still, you might even loop back into the past. That's when you get those deliciously strange paradoxes. What happens if you meet your younger self, or stop an event that led you there in the first place? It's the kind of idea that's fueled entire genres of science fiction. But here's the kicker: the math doesn't forbid it. Wormholes are allowed by the equations of general relativity. They're not proven to exist, but they're not ruled out either. They sit right in that sweet spot between theoretical science and imagination run wild. Sounds incredible, right? But here's the brutal truth: keeping a wormhole open is way harder than just finding one. The math says a natural wormhole would collapse instantly the moment you tried to enter. To stop that from happening, you'd need something extraordinary exotic matter. This isn't your everyday fuel or some metal from a sci-fi movie. Exotic matter would have to have negative energy density, something we've never seen in usable amounts. A kind of material that literally holds space open instead of letting it snap shut. And even if you had that, you'd be flying into a gauntlet of extreme forces. Inside a wormhole, gravity could stretch and crush objects like spaghetti. Radiation levels could fry electronics, tear apart a ship, or vaporize a human long before they reach the other side. So, for now, wormholes live in the realm of theory possible on paper, but completely out of reach with today's technology. That doesn't stop scientists from looking, though. Every new discovery about gravity, quantum physics, and space-time could bring us a step closer to knowing if these cosmic shortcuts are real, and if they're safe. And now I'll ask you one. If you could step through a wormhole, would you? Tell me in the comments. And if you love chasing the impossible, hit that subscribe and join me for the next journey.